Students, I know all of you were desperately waiting for this particular session, your complete salt analysis in just 10 to 15 minutes. So in this particular session, I'll be discussing the complete salt analysis topic in just 10 to 15 minutes. And you can expect 2 to 3 questions for sure when it comes to the NEET 2026 examination. But one thing I'm going to tell you, the salt analysis is completely memory based. Okay, it's completely memory based. There is no conceptual stuff and all, right? You have to revise it again and again, then only you will be able to remember all the things which I'll be letting you know in this particular session. And at the same time, the PDF of this particular session I'll be sharing on my Telegram. The name of the Telegram channel is Wassim Bhat Chemistry Official. WASSIM BHAT Chemistry Official is the name of the Telegram channel. So without wasting a lot of time, let's get going. Let's get started with the salt analysis. My dear students, first thing, my dear students, we have got the first type of stuff. What is that? That is the acidic radicals. Your anions are also called as acidic radicals. And in the acidic radicals, my dear students, we have got 2 groups. Group 1, which are going to react with HCl, and group 2, they react with H2SO4. What all anions are there in group 1 and what all anions are there in group 2? My dear students, group 1 contains your carbonate, acetate, sulfite, and sulfate. These are the group 1 anions basically. These are the acidic radicals of group 1. Similarly, acidic radicals which are in group 2, that is your chloride, iodide, and nitrate. So basically we have to check what are the different tests which are related to all these ions. So let's get to know about that one by one. So first of all, let's talk about your acidic radicals, my dear students. The first ion which you are seeing over here, that is your S-di negative. Now in S-di negative, what all tests do we have? In S-di negative, I would say we have got 2 tests. One is called as lead acetate test. One is called as sodium nitroprusside test. My dear students, in lead acetate test, what happens exactly? Let me tell you, if you will be having S-di negative in a container, and you will be introducing your lead acetate in that particular container, what does it form? That leads to the formation of black PPT, black precipitate. So basically, for example, you have got a container that's full of S-di negative ions, but you have no idea there are S-di negative ions in the container. You know there are some ions in the container and you want to check which ions those are. You have got a container in which there are some ions. You want to check which ions those are. Now, if they were S-di negative ions, then at that point of time, when you introduce lead acetate into that, you'll be getting black PPT. That's how you detect S-di negative ions in the solution. Number 1. Number 2, sodium nitroprusside test. Again, my dear students, your sodium sulfide is going to react with this particular complex, and what do you get? You get a violet color, sodium nitroprusside, you call this, right? These colors are very important and you have to remember them. Perfect. Now, what about your chloride? My dear students, in your chloride, again, I've got 2 tests which you have to remember. One is called as chromyl chloride test. One is called as chromyl chloride test. What happens in that? You'll be taking NaCl, right? You'll be taking NaCl. NaCl is going to react with your K2Cr2O7 in acidic medium. What does it form? It forms red vapors, your CrO2Cl2, which on further treatment with NaOH forms Na2CrO4, which is yellow in color. This is something which you are going to remember. So basically, for example, you have got a solution. Solution contains some ions. You have to check which ions those are. Are those chloride ions or not? Then what do we need to do? You need to introduce K2Cr2O7 in acidic medium. If at the end you get a yellow PPT, yellow precipitate, that means there are chloride ions present in the solution. Okay. Similarly, AgNO3 with Cl negative, it again forms the white PPT, that's your AgCl. Perfect. This is again one more test by means of which you can detect whether there are chloride ions in the solution or not. Okay. I know this is something which you have to remember. And it's not easy to remember. So for that, you have to revise it again and again. And all this I'll be sharing on my Telegram. The PDF of this, the name of the Telegram is Wassim Bhat Chemistry Official. Wassim Bhat Chemistry Official is the name of the Telegram channel on which I shall be sharing the PDF of this particular session as well. Okay, moving on to one more. Detection of bromide ion. What happens? Bromide on reaction with AgNO3. It forms AgBr, that is pale yellow precipitate. Okay. Similarly, my dear students, your Br2, which is basically Br2, it has got brown color. These are brown vapors. On reacting with water, what do we get? We get brown solution. Now, there is one more gas, which is basically brown in color. That is your NO2. That's your NO2. Now, how can you detect whether the brown gas is your Br2 or NO2? When NO2 reacts with water, it forms no brown solution at all, right? So First of all, your Br2, which is basically your brown vapors on treatment with water, it forms brown solution. Your NO2 on treatment with water, there will be no brown solution. This is the how you distinguish basically whether the gas is your Br2 or NO2, whether it's Br2 or NO2. Similarly, iodide test. My dear students, first of all, your I2, it's basically violet fume, your I2, right? And when I2 reacts with starch, it forms a blue solution. Perfect. Now there is a test for it. That is a layers test. When you take a salt solution of I negative, when you take a salt solution of iodide, let's say you're taking some salt solution of iodide, on treatment with dilute H2SO4, that too with chlorine water, right? Salt solution of I negative with dilute HNO3 and chlorine water. What do you get? You get a violet layer. Perfect. You get a violet layer. This again, something which you have to remember. This is also important. My dear students, moving on to nitrate. Perfect. In nitrate, what do we have to remember? Your NO2, my dear students, it is your brown smoke, right? NO2, brown smoke. There's a test called as brown ring test by means of which you can detect the nitrate ions in the solution. What happens basically? FeSO4 plus NO3 negative salt, the salt of NO3 negative on treatment with FeSO4 and concentrated H2SO4. Perfect, right? What does it give? It forms this particular complex. You call this as brown ring. And my dear students, one thing is important. In this brown ring complex, the oxidation of iron is +1. Remember, this is asked again in your examination. The detection of sulfate. My dear students, small amount of SO4 dinegative on treatment with concentrated H2HNO3 and BaCl2. It forms BaSO4. That's again your white PPT, white precipitate. Similarly, your carbonate test. My dear students, if you take a salt of a carbonate, right, on treatment with HCl, what do you get? You get carbon dioxide. And my dear students, you know, lime water turns carbon dioxide milky. So what do we get basically? So for example, you take salt of CO3 dinegative on treatment with HCl, it forms carbon dioxide. The same carbon dioxide on reaction with calcium hydroxide, it forms calcium carbonate. Perfect. So lime water turns milky in this particular case. Again, important. Similarly, your acetate ion. There is the first test for acetate ion, that is your pollen test, right? What happens in this pollen test? My dear students, if you take the salt of this acetate ion if you take a salt of this acetate ion and if you treat it with oxalic acid, you get the smell of vinegar. So by means of which you can detect whether in the salt there were acetate ions or not. If you get the smell of vinegar, that means there were the presence of acetate ions in the solution. Okay. Then you have got sulfite. My dear students, when you take the salt of the sulfite on treatment with dilute HCl, what do you get? You get the smell of burning sulfur, right? Similarly, when you take this same sulfite, sodium sulfite, right, on treatment with BaCl2, what do you get? You again get white PPT, that is your BaSO3. Okay. Similarly, these were your anions. Now let's talk about the tests for the cations. My dear students, your cations are called as basic radicals, and there are groups like group 1, group 2, group 3, group 4, group 5, right? Even the zero group, perfect for the cations, right? Now let's talk about group 1 cations. Let's talk about those cations which fall into group 1. In group 1, Ag positive, Pb di positive, and this mercurous ion, right? They fall into your group 1. My dear students, remember the reagent used is HCl and the solvent used is HNO3 when I talk about the detection of these ions. Okay. Now you have to remember few things. Your Pb di positive. Here you have got PbCl2. That means it contains Pb di positive. Pb di positive on reaction with K2 CrO4. What do you get? You get PbCrO4. That's a yellow precipitate. Similarly, Pb di positive here, right? You take PbCl2 on reaction with potassium iodide. You again get a yellow precipitate. So this is how you detect whether Pb di positive ions are present in the solution or not. Similarly, Hg2 di positive, your mercurous ion, Hg2Cl2, mercurous chloride, on reaction with HNO3, on reaction with NH3, it forms black precipitate. Similarly, Ag positive detection. Ag positive on reaction with I negative, you get a yellow precipitate here in this particular case. Moving ahead, group 2. In your group 2, you have got Hg2 positive, Pb di positive, bismuth tri positive, copper di positive. Reagent used here is H2S, solvent used here is HCl. Now, my dear students, remember Hg di positive. On treatment with SnCl2, it forms white precipitate. That's your Hg2Cl2, mercurous chloride, right? Pb di positive. On reaction with H2SO4, it forms white precipitate. Again, on reaction with CrO4 di negative, it forms yellow precipitate. Perfect. Similarly, the same Pb di positive on reaction with I negative, it again forms the yellow precipitate. These are the colors which are important, and they'll be asked in your examination, my dear students. Similarly, detection of Cu dye positive. Cu dye positive on reaction with on reaction with ammonium hydroxide, you get a dark blue complex. This is your dark blue complex. This is a famous complex which you study in your coordination chemistry, CuNH34 dye positive. Similarly, this is also important. Cu dye positive plus K4FeCN6, right? What do you get here? You get chocolate or red brown color. You get a red brown colored complex here, right? When Cu dye positive is treated with your K4FeCN6. Perfect. This is also important. Take a note of it. Now, similarly, your bismuth tripositive. This again belongs to your group 2 category only, right? This BiCl3 on treatment with water, it again gives you white precipitate. My dear students, your group 3. Group 3 contains these 3 cations, and the reagents uses NH4OH plus NH4Cl. Solvent uses dilute HCl. Now, first of all, these are the hydroxides. These are the hydroxides of these ions. These are the hydroxides of these ions, and you need to remember their color first of all. Aluminium hydroxide is white in color. This FeOH whole thrice is red in color, and this is green in color. Now, what happens? What happens? Detection of Al tripositive. Suppose you have got AlOH whole thrice. You have got aluminum hydroxide, right? Which is amphoteric in nature. On treatment with NaOH, right? So this NaOH is going to behave like a base. If this is behaving like a base, so this is going to behave like an acid. So what do you get? You get NaAlO2, which is soluble, right? It's not a precipitate. Cr tripositive. You get the hydroxide of this chromium, right? On treatment with bromine water and BaCl2, what do you get? You get BaCrO4, barium chromate, which is yellow color. Similarly, Fe tripositive detection. Fe tripositive on reaction with your potassium thiocyanate, it gets a complex that is blood red. It is a blood red complex. Your FeSCN thrice. This is also important. Remember this particular thing as well. Now, similarly, my dear students, your group 4 contains these ions: cobalt dye positive, nickel dye positive, manganese dye positive, zinc dye positive. The reagents used are H2S and solvent uses NH3. Now, my dear students, Ni dye positive. On treatment with your DMG, what does it form? It forms a red colored complex. I know it's very hard to remember, but you have to remember this. Similarly, cobalt dye positive, right? Finally, it forms what? Ammonium cobalt thiocyanate on reaction with NH4CNS. Okay. Zinc dye positive on reaction with NaOH, it forms white PPT, and this zinc hydroxide again on reaction with NaOH, it forms zinc sodium zincate basically here. Similarly, Mn dye positive on reaction with your sodium hydroxide, what does it form? It forms MnOH2 twice, which is basically pink precipitate. Then on further heating, it forms MnO2, which is your brown black colored thing. This is your brown black colored substance which you get at the end, by means of which you detect whether in the solution there are Mn dye positive ions or not. Similarly, my dear students, group 5. Group 5 contains these cations: Ba dye positive, barium dye positive, strontium dye positive, calcium dye positive. This is the reagent used. Now your barium dye positive on reaction with K2CrO4, it gets a yellow color. Similarly, Ba dye positive on reaction with this, you get white color. Here also you get white color. Similarly, strontium dye positive on reaction with this particular substance, your ammonium sulfate, you get white color, right? White colored precipitate. Similarly, Sr dye positive on reaction with this particular substance, right? Which is your basically ammonium oxalate. Perfect. You get a white colored PPT also. Calcium dye positive on reaction with ammonium oxalate. What do you get? You get white colored PPT here also in this particular case. These are again the important ones which you have to remember. Similarly, my dear students, there is group 0 as well. In group 0, there is NH4 positive ion and Mg dye positive ion. Now, Mg dye positive on reaction with this particular substance and NH4OH, what do you get? You get a white PPT here. Similarly, NH4 positive. It releases NH3 on reaction with NaOH. This also important point. NH3 on reaction with HCl. What do you get? NH4Cl. All of you know, white fumes, right? Similarly, brown PPT with your Nessler's reagent. So NH4Cl with this particular substance in presence of KOH, what do you get? You get Millen's base. This is called as Millen's base, which is basically a black-brown PPT you get in this particular test over here, right? By means of which you check whether there are your NH4 positive ions present in the solution or not. Similarly, there are a few more things which you need to remember. That is the color of cations. Your nickel dye positive, copper dye positive has got blue or bluish green color. Fe tripositive has got brown color. Cobalt dye positive, pink violet, right? Similarly, your Fe dye positive, it has got your light green color. Ni dye positive, green color. Mn dye positive, light pink color. Similarly, my dear students, when I talk about the solubility, this is the last slide over here. When I talk about the solubility, these are few pointers which are mentioned and anything can be asked out of these pointers. My dear students, all the halides are soluble. All the halides are soluble except the halides of silver, except copper, except mercury, except your lead. Right? All the halides are soluble except these. Similarly, all nitrates are soluble, no exception. All nitrites are soluble except AgNO2. Right? Similarly, all sulfates except silver, strontium, barium, lead, mercury, calcium, tin, they are soluble except these. Perfect. Similarly, all acetates are soluble except silver and mercury. Right? And what all do we have? The insoluble salts. Insoluble salts are the carbonates, oxalates, S dinegative, SO3 dinegative, except alkyl and your ferrous oxalate, which are basically soluble. Perfect. My dear students, this is just your salt analysis, which you have to remember. I know there is no concept at all. Perfect. It is very difficult to remember this, but questions will be asked from these 13 slides, which I've used over here. From these 13 slides, 2 to 3 questions for sure will be asked, right? So I'll be sending the PDF of this session in my Telegram. Do check that PDF once. That's going to be super beneficial for you guys. Okay. And do read it 2-3 times every day for like 10 to 15 minutes every single day at night. Eventually, you are going to remember all the colors for all the tests of all your cations as well as the anions. Right. With this, I'll be taking a leave. You take care. God bless you all and love you all, guys. Bye-bye.